Today we're going to take a look at how we solve for area of a parallelogram. First, please note how we spell parallelogram with double L and another L to follow. There are two ways to look at parallelograms. For example, we can split it into a triangular shape and we can rotate this triangular shape to fill in this missing part, and voila, we have a simple rectangle, and it's just length times width. That's one way of looking at it. And of course, it's length equals 8 and width equals 6. So this particular shape, the yellow shape, would be 48 square units. There is another way to look at parallelograms. We can split them using the diagonal line into two triangles. And then we would consider a left triangle and a right triangle. And we could solve for an area of a triangle as a half times base, half of base times height. And this would be, the base would be right here. Remember, we learned to identify base in our previous video. And this would be the vertex opposite of the base. And this would be the height. So we could find that, and of course that would be area of this triangle would be a half of 8 times 6, which is 24 square units. And then we would consider the second triangle, the right triangle, this shape. And again, we would look at it from the same point of view. We would first find the base, and the base would be equals to 8 units. And then we would find the vertex opposite of the base and drop a perpendicular line, which would be our height, equals to 6. And again, area of the red triangle would be a half of 8 times 6, which is also 24. When we add 24 and 24 together, the area of a parallelogram would be equal to 48 square units, which is exactly what we had above. So yes, please think about it as 2 points of view on a parallelogram. One is that we complement the triangle, and another way we can look at the parallelogram as two triangles. Therefore, we can derive the formula for parallelogram, and that is area of a parallelogram is simply base times height. Kind of like finding two triangles, right? Instead of doing half of base times height, we would do base times height alone. So here is our base, and we find the vertex opposite of the base and drop the perpendicular line, 90-degree angle, just like we did with triangles, and that is our height, which is exactly this quantity. This is the height. So let's practice. I'm on page 141, and we're going to consider examples 2A, B, C, and D. I'm going to solve them all. Let's go, friends. Step 1. In all of these exercises, it's always a good idea to first identify a base. Let's take a look at 2A. This would be the base. This would be the base. In example B, this would be our base. Let's label it base. The blue line is a base, which is kind of intuitive because that's the downside, right? The bottom part of your parallelogram. Let's consider example C. Here our parallelogram is rotated. No problem. We can always find our base to be this line. No problem. We can always change our point of view. And also in example D, we can change our point of view by rotating our parallelogram or rotating our books or a page and find this to be the base. So in these examples, base equals to 7, base equals to 3, and base equals to 5, and here base equals to 15. Now step 2 is very important. Step 2 is finding the height. There are two parts to this, to finding the height. Part 1, find the vertex opposite of the base. It doesn't matter which vertex you pick. Obviously, there are 4 vertices in a parallelogram. It's a quadrilateral. Find the vertex, a vertex that is opposite of the base, and drop the perpendicular line down to the base. Look at example B. Find the vertex opposite of the base and drop perpendicular line down to the base at 90-degree angle. Take a look at example C. Here our parallelogram is twisted. It's rotated on the page. Find the vertex opposite of the base and drop a perpendicular line down to the base. Now in example D, we have a very, very skewed, right? A very angular parallelogram. No problem. Find the vertex opposite of the base. Look how far it is. No problem. We can extend our base with a dashed line and drop a perpendicular line to the base, which is exactly equal to 4.5 centimeters. So all you need to do, friends, is complete your calculations, okay? We just need to complete your calculations. So 7 times 12, of course, that's 84 square inches. 3 times 3/4 is 2 1/4 square centimeters. 15 times 12, 15 times 12 equals 180 centimeters squared, and 5 times 4.5. Remember, multiplying fractions by mixed number, multiply 5 times 4 and multiply 5 times 1/2. Create your partial products, friends, much easier to do. This is 20 and this is 2.5, and together the area is, add the partial products, 22.5. This is a 2, of course, centimeters squared. Ooh, look at that. Now, finally, composite shapes. Composite shapes. We do have few choices here, and let's consider all of them. Part 1, we have a square that is 2 by 2. Okay, find the area of that square, and then look at part 2. We have a rectangle that is 2 by 3. Also, not a very difficult question, I would say. You can all agree that the area of this piece would be 6 square centimeters. The area of the square would be 4, and together we have 10 centimeters squared for the area of this shape A. That is super easy. Now, my friends, we will have a much more advanced examples. Let's split our page so we stay organized. This will be space for example B. This will be space for example C. And finally, example D. So let's start with example B. We have multiple shapes here. Let's identify them. Shape 1 is a parallelogram. This is the parallelogram I'm highlighting in orange. Step 1, let's find the area of a parallelogram. You see, I use this little, this little symbols. Area of a parallelogram is base times height, which is the same as 9 inches times, take a look, we find the vertex that's opposite of the base, and we drop the height, and that's 6 inches. So we have 54 square inches for the parallelogram piece. Now, the second part, I'm going to do it in blue. We have this triangle. We know how to find the area of a triangle. We have to identify area of a triangle. You see how I use the symbol? Is a half of base times height. Therefore, it's 1/2 times 6, which is your height, and times 7 1/5. I would suggest you do this operation first, and then you have 3 times 7 1/5, which is equal to 3 times 7, 21 3/5. 21 3/5. So that's the second part, but my friends, we're not finished. We need to put these two areas together. In the third and final step, we're going to add 54 plus 21 3/5, and we get 75 3/5 inches squared. And that is the area of shape B. I hope you find this information useful. We are on page 142, and I will follow up with the next video.